Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello students, I'm Callixte. I teach mathematics in Senior 3. The lesson of today is about mathematics for Senior 3 on unit number 6, linear and quadratic functions. We sometimes see things in life. Car moving, plane taking off, a child on a bike. These are the examples of the things we see in everyday life. But somebody can ask him or herself, why all these things are happening? All these things, we will learn about them in this unit, linear and quadratic functions. But today, we are going to learn a few points under this unit. That's why, under this unit, linear and quadratic functions, we are going to discuss point number 1, which is 6.1, linear functions. Linear functions. You can ask yourself, what is a linear function? And why do I need to learn this? I want to explain to you this. The whole title, linear function, it has two terms. We have linear and we have functions. The meaning of this word linear, it means you need to arrange things on a straight line. When you are arranging things on a straight line, you are dealing with the linear. You are now trying to explain this word, linear, means arranging things on the line. And if I try to explain a function, I can say a function is like a machine. If you consider like a machine, let me try to show you this. Like a machine. And under this machine, you put there the input, and it gives you the output. It gives you the output. Remember, in Senior 1, there is what we learned. When you have input as an fx, which is, for example, equal to 2x plus 1, you can have the input for x. When you bring in a value of x and you enter in this, what I have called a machine, which is a function, it gives you the output. You only replace the value of x and you get the value of this fx, which we normally call it y. So I hope we have understood what is a linear function. In a few words, any function of the form y, which is equal to mx plus b, any function of this form, it's called a linear function. Look at here. I have tried to put in different colors. We have y. This explains to how far you are going up. We have m. This is gradient. And we will talk about it. We have also x. It explains to us how far you've gone along, just on a horizontal line. And we have b. This is the value of y when x is equal to 0. I think everyone is understanding this. Okay? Now, from there, if I have this mx plus b, this is the general form of a linear function. We actually call it a general form. A general form of a linear function. But many of the students just wonder, when do I have to call this a function and when do I have to call this equation? I want you to understand this. There is one thing that I want you to understand. Whenever I give the values to M and to B, this whole one will be called a linear equation. It will be called a linear equation. For example, if I give M maybe the value of 2 and I give B as the value of 3, of course, I will get this, which is equal to 2M plus 3. And from here, I call it a linear equation. Do you get this? Let me repeat this one more time. When I have a general form written this way, y, which is equal to mx plus b, this is a general form of a linear function. But when I replace m by its value and b by its value, I will call this one, or it will become a linear equation. So whenever you see somewhere written y, which is equal to any value, sorry, this is not m, it is x, any value like 2x plus 3, or maybe y, which is equal to 3x plus 2, and so on. All these forms, we call them the linear equation. I think you get this. Now, we are going to learn something also new under this linear function. From here, we need also to specify what each and every letter stands for. Whenever I have m, which is equal to m, x plus b, I want you to know this. This m, we call it slope. We call it slope, or we can also call it a gradient. A gradient. This is it. It means when you go back on this linear equation, now the value of m here, it is 2. And the value of b here, it is 3. From here, you can give yourself an example of a linear equation or a linear function. So now, I'm going to give you the other knowledge about the slope or a gradient. Give me a minute, and then I clean over here. So, we need to know what is a slope. What is a slope? Or gradient. A slope is very important in our everyday life. For example, when you take this school box and also this step, if I try to put school box on my tape like this, there is a change of how it has been before. If it has been like this, and I change it at this level, it is now inclined. I get what we call inclined plane. This is actually what you call a slope. Let me take this ruler. It will show us properly. I have this ruler on this flat surface. But if I try to incline, it will incline at this point, Now I'm changing what you call a gradient. A gradient can go up or down like this, or I can check it in this way. That's why at the end of this lesson, we will be knowing how many types of slopes do we have. But before we go far, a slope is actually a ratio. Remember, we have said a slope is symbolized by the letter m. This is actually the change in y coordinates over the change in x coordinates. But you can ask yourself, what is change of y coordinates? Or what is change of x coordinates? Simple. I'm going to show you. Look at this. Look at this point. We have a graph. We have x-axis and we have y-axis. Remember, we want to know where is the change in y-coordinates and where is the change in the x-coordinates. Come here now. This is what we call Cartesian plane. I guess everyone remembers this. For a Cartesian plane, we have x-axis and the y-axis. I have made something that can help you to understand more. Look at this. It's just improvisation that I have made to make you understand where is the x-axis, where is the y-axis. If I have this, here we have y-axis, and here we have x-axis. If we consider any surface that is made by two lines, this line going up and down, of course, which is called y, and this one, which is called x, now we are in what you call two dimensions. I want you to remember this, in two dimensions. So, when you come back here, we have y-axis and we have x-axis. This is a line that we are given. That is how x may be from 0, it has changed. Maybe from 1 to 2 to 3 to 4 to 5 and so on. You are seeing how x is changing. X is changing. And at the same time, y is also changing, going up from 1 to up to 3. I have a very nice diagram that can show you this. Very nice diagram that can show you this. Put it here. Look at this. This is what I was talking about. Oops. You see, we have been saying that a gradient is equal to the change in y coordinates over the change in the x coordinates. When you look at this, we have x-axis and we have y-axis. This is what you call the change in x. And this is what you call the change in y. So when you are calculating the gradient of any linear equation, you need to work on this gradient. Now, for example, if you go back again and look at this example, we have now a line. And the point here, if you've sketched a line, it has passed the 2 points. Remember this. Every line needs at least the 2 points to be sketched. For our example, we have point A. Let me call this as a point A. It has the coordinates -4 and 0. And I also have another point, which is called the point B, with the coordinates 0 and 3. You see? From here, if I have 2 points, it's easy for me to calculate the gradient. Remember, we have said the gradient is equal to the change in y over the change in x. What does it mean? I have to go here and see the first point and also my second point. I name this as x1 and this one as y1. And I also go here and name this as x2 and this one as y2. Now, I'm almost to see the answer. I come back here. When I say the change in y, it means I will take x2 minus x1 over, y2 minus x1 over x2 minus x1. Now I replace the values. How is equal y2? y2 here is equal to 3. How is equal y1? y1 is equal to 0. How is equal x2? x2 is 0. And then, what about x1? x1 is negative 4. This is what we have. Now, you calculate. 3 minus 0, it is 3. Then 0 minus, when you have minus and minus, it gives you positive. Now I have 4. You see, my gradient, or the gradient of the line, it is equal to 3 over 4. Everyone is understanding this. Now, I'm going to give you one activity. Then you work on it. So, work on this activity. Suppose that I have points. Suppose that I have points A, which has coordinates 2 and 3, and points B, which has maybe 4 and 2, or maybe 1. You see? Find the gradients. Find the gradients. So let me give you 2 minutes, and you work on this, and we'll come back, then we work on it together. 2 minutes. Thank you. Let's do it together. As a solution. Remember, when you are looking for the gradients, you need to look at the change in y over change in x. This is x1, and this is y1. This is x2, and this is y2. Now, y2 is equal to 1 minus y1 is equal to 3 over x2 is 4 minus x1, which is equal to 2. Now I have negative 2 over 2. And I can simplify my fraction. If I simplify by 2, here I get negative 1 over 1. And of course I get negative 1. Means the gradient of a line that passes through these 2 points is equal to negative 1. You see? Very easy. Now, we need to know what is a positive or a negative slope. There is a very nice sketch here. We have a child who is on a bike. You see? And you have also when he or she reaches here. And when he is climbing, riding on a bike. Now, whenever we have a line sketched like this, it means we have a negative slope. And also whenever we have a line sketched on a horizontal line like this, we have no gradient. It is equal to 0. Whenever we have a line sketched going up like this, now we have what you call positive slope. In other words, we have what you call positive slope, negative slope, and there is a case where we don't have any slope. Thank you. Well, why do I need to learn this in everyday life? Why? Many of the times people say, why do I need to learn this? But slopes are very applicable in everyday life. You see? Did you know? Slopes or gradients can be applied in economics. In economics, you can apply there the slope. When you want to look at the relationship between the demand and the supply, you need to look at this gradient. Whenever the commodity, the producers need a quantity to be given to the people, and also whenever the quantity of the things people want to buy, which are the demands, we need to look at these two graphs. When the quantity of the things needed by people is increasing, you have to make sure that also the supplier have to produce a big quantity of the things people want. And this gives us what you call the equilibrium of these two graphs. It gives us the price. You can learn this in economics, especially in the university classes or at university. We also apply gradient in physics when we are learning about motions of the things or of the objects. When we are looking at the graph of velocity and the graph of time, against the time, when the graph is going up like this, it means velocity is increasing. And when you look at the graph and you realize that velocity is declining, there is a name of that motion of an object. Simple. We have so many different applications of slope in our everyday life. As I have been showing you this, seeing how something is inclined, or maybe a plane is inclined, or maybe when we are learning about the Cartesian plane, when you are drawing the lines, all these are the things we use gradient in everyday life. Or remember, when we are seeing cars moving on a straight line, or maybe when a plane is taking off, it has to follow a straight line. All those are the things we see in everyday life. Now, I think I can give you enough time to work on the homework. But before, we are going to read this homework. After reading the homework, I will help you with only one question, and you will do the rest. This is the homework. You can work on them. For each of the following pairs of points, find the change in the x-coordinates and the change in the y-coordinates. Hence, find the gradient of the lines passing through them. We have question number A. We have point A. It has coordinate 0 and 2. This one has 3 and 4. Second question. We have point which has the coordinate 0 and 2. And another point has 5 and 0. We have another point has -1 and -2. Another one has 1 and 8. We have another point that has -2 and a 0. Another one has 3 and a 0. We have another point that has 0 and -2. And another one has 0 and a 3. I'm going to do one question for you. And then the rest you're going to copy and you work on them as homework. For the moment I'm cleaning, just copy them in your exercise notebook. And then we're going to do one together. And then we'll be done with the lesson of today. Let's do one question together. We have 2 points. We have one point has 0 and 2. Another one has a 3 and 4. The solution is to find the gradient. Remember, gradient is equal to the change in y-axis over the change in the x-axis. This is x1, this is y1, this is x2, this is y2. y2 is equal to 4 minus y1, which is equal to 2, over x2, which is equal to 3, minus x1, which is equal to 0. And of course, we have now 2 over 3. So the gradient of a line which passes through these 2 points is equal to 2 over 3. I think you've understood. Thank you very much. We will learn the next point next time. So keep revising, and we will continue with the second point under this unit, especially on linear function. Thank you very much.